I know that you've been asking for a long time. We're finally going to talk about the best digital mesh radio for ATAK and other applications. So ever since the very first ATAK video on the main TREX channel, I forget how many years ago, you guys have been asking about Meshtastic radios. And ever since the very first video on the TREX Labs channel, which was about the MkII and Silvus radios and other kind of high-end commercial ones, you guys have been asking about all sorts of different things, from goTenna to Beartooth, the Auto Lynx Pro, and all these things are going to be discussed now. Now, this video isn't going to be one where we go out in the field and we test a lot of this stuff. We've already done a lot of that. This video is going to be about the conclusions, and we're going to look over all of these different things. But as you probably know, mesh networking radios are the future. The idea is that you can transfer traffic from one radio to another, forward the communications, which gives you a lot more capability with a lot less infrastructure. No more giant, expensive, power-hungry repeaters that have to be programmed separately. You will have a mobile ad hoc network that is created by the devices themselves as you move around and do stuff. It is the golden age of digital radios. Or it will be, because some of this technology is still in its infancy, but it's coming rapidly and it's coming soon. There's a lot of regular Wi-Fi adapters now that have the newer Wi-Fi 6 different protocols and chips that do packet forwarding and addressing and stuff. So this is the way that a lot of radio stuff is going to go. But let's talk about the stuff that you can buy that primarily works with ATAK. I think that you guys are primarily interested in ATAK. But in this video, we're going to be primarily looking at 3 different radios. We're going to be looking at the Meshtastic, we're going to be looking at the Beartooth Mark II, and we're going to be looking at the goTenna Pro X2. We're going to be comparing all of these. So first of all, let's just lay them out according to price. Over here we have the Meshtastic radios, and the internet will tell you that these are 30 bucks. And that's kind of true. They are basically 30 bucks if you buy just the internal components and kind of assemble them yourselves. But if you want them to be in something that is a little bit better enclosure than a small waterproof pot, you are going to need to figure that out yourself and possibly print it yourself or buy it on Etsy from a friend. You're going to need antennas, you're going to need probably some kind of battery to make it work. So now you're looking at a little bit more than 30 bucks. Fortunately, Rack Wireless has started to sell complete units for 100 bucks. So we're going to say a Meshtastic node is going to run you about 100 bucks. Then you have your Beartooth units, and your Beartooth units sit right in the middle of this particular spectrum here. If you look up Beartooth on the internet, you will find that they sell for $1,250. But here at TREX, we actually have a coupon code for you, a referral code. It will allow you to get these for $750. The code is TREX, T-R-E-X 40. Later on in the video, I'm going to explain why we have an affiliate code for Beartooth and why we're not making any money from it. This is just Beartooth, the company, and us giving you a discount. So these radios come in at 750 bucks, and then the goTenna radios are a little bit different because they're kind of hard to buy. They don't want to sell them just to regular people that don't have a business band license because they are encrypted and they run on business band frequency. So they have some extra hoops for you to jump through, but they are basically twice as much as the Beartooth radio. So now we have a nice gradient here in price, and we're going to compare that to a whole bunch of different things. We're going to look at the range of the radios, the privacy and security, the features, the usability, the configurability, the durability, and go over all of these things. If we combine all these things together, we get a performance line that tracks pretty closely along the price. Now, if you're developing a product, this is good. You would like the performance of the product to match the prices of the other products of the same performance level. If you have something that is way better for less money, you probably could have charged more. And if you have something that is way worse, then you obviously should charge less. Now here at TREX, we like to find things that offer you just a little bit more performance per price, or, you know, sometimes a lot more performance per price. We would like to be above the line. And as I've compared all these different devices and done different types of testing and looked at the market and the stuff that's coming, these things make a pretty good line, and Beartooth is right in the middle. But like everything, it depends. It depends on what it is that you're actually trying to do in the environment you're trying to do it in. The single line and the single metric doesn't quite cut it. So let us talk for a little bit about range. When most people have radio questions, the first thing they ask about is range. How do you get the maximum range? How far can this radio actually go? And with the mesh radio networks, that is complicated because ideally you have enough radios out to create a mesh where this traffic goes from here to here to here, etc. So the range is going to be computed by the entire mass of nodes and the obstacles in between, not just simplex one particular radio to another. But generally speaking, we're going to have range that looks kind of like this. Now the Meshtastic here operates on 900 megahertz. It uses low raw, low power, long range Internet of Things protocol. It pre-exists. Then the Beartooths use a different protocol, but also on that 900 megahertz range. And then over here on the goTenna Pro, you have VHF and UHF frequencies. So lower frequencies that can go further and a lot more power. 5 watts for these, 1 watt for these. And then because Meshtastic nodes can be built using almost any radio that you buy off the shelf for this particular Internet of Things area, some of them are a watt, some of them are 100 milliwatts, somewhere in between. So it varies. But what's interesting is if you look at the MkII and the Silvus radios over here, they are geared for super high bandwidth so that you can control drones and have real-time telemetry, and you can get video feeds from cameras and various things. So that need to push a huge amount of data means that they are generally operating at much higher frequencies, 1000 gigahertz or up, 2.4 gigahertz like your regular Wi-Fi, and at higher wattages. So the MkII, I think 6 watts, then the Silvus Streamcasters go up to 20 watts. So they are kind of in a different class. I'll refer to them occasionally, but again, we're looking down here at these sort of 1 watt or lower radios that focus on less traffic and push for more range. But on the flip side of range is privacy and security. Now, a lot of folks on the internet think that privacy and security are the same thing for radios. They really aren't. Security would be encryption, and all of these radios can do encryption. AES 256-bit encryption is the standard for all of them, and that is quite secure. But if you are transmitting in the middle of somewhere, you are no longer private if your messages can be received, if they can be detected, if they can be intercepted. And so a lot of radios for a lot of jobs are actually more interested in a low probability of an intercept than they are on maximum range. So the goTennas over here at 5 watts definitely would prefer longer range between the nodes as opposed to flying under the radar, so to speak. Now the Meshtastic devices over here have a couple of advantages. The first is way less power, and then the second is 900 megahertz doesn't stick out quite so much in certain areas. There's generally a fair amount of ambient noise in the 900 megahertz space. There's commercial sensors and there's industrial communication going on, so it doesn't really stick out as much as transmissions in the business band area where you would expect goTenna radios to be and pumping out 5 watts of power. Now that is a pretty significant downgrade in range over here. But again, if you have mesh nodes and you spread them out, you have the ability to hop your traffic farther. And the lower cost means that you could actually compete with some of the higher power, longer range radios if you plan things out properly. Now, speaking of privacy, a lot of people on the internet believe that because these are spread spectrum protocols, they are harder to detect. They do frequency hopping. They work across different channels. And that doesn't really hide your transmissions anymore. In the past, frequency hopping was a great way to be almost invisible. Today, modern electronic warfare equipment, even just basic SDRs that you can buy for 20 bucks, see enough spectrum that frequency hopping signals inside are still visible the whole time. What frequency hopping gets you, or spread spectrum transmission gets you, is it works around interference better. It might even help you overcome some light jamming better, but it doesn't really hide you in the 21st century. Privacy is still a major concern, and not to be confused with security. But let's dive into the features of these radios and what it is that they actually do. I mentioned that over here, the really high-end radios, the $10,000 and up radios, the MkII, the Silvus radios are designed to send huge amounts of data. You should be able to drive bomb disposal robots and see multiple camera feeds for them at all times. You should be able to do all kinds of amazing aerial vehicle stuff. And these things are much more limited. But they do work with ATAK. The main thing that you probably want to do, based on the fact that our ATAK videos are some of the most popular on the channel, is work with ATAK. And the best way to connect ATAK together is going to be, if you're on a budget, some of these devices. And with ATAK, there's a number of different things that you will want to communicate. The first and foremost is probably your location. You want to be able to show other people who you trust on your team where you are on the map, see where they are on the map. That LPI data can be transmitted by any and all of these radios. Then you probably want to be able to drop pins so you can indicate areas. And then you want to be able to send small text messages between each other. And again, all of these radios can do that. But some of the more complicated ATAK information, some of the routes, some of the shapes, some of the images, those are no longer supported by the Meshtastic plugin or the goTenna plugin. But the Beartooth plugin actually allows you to send everything up to and including images, although they go pretty slowly, and data packages, but you should send pretty small ones. And it also lets you do voice. There are no buttons on the Beartooth device. The only thing that you can do is turn it on and then connect it to ATAK. But once you are in ATAK, you have a push-to-talk button, and that allows you to send voice over IP communications throughout your network. Speaking of usability, I want to mention that all of these devices do have their own apps that will allow you to work outside of ATAK if you want. And they also have pretty good ATAK plugins so that you can do the communication from within if you want. But I do think that Beartooth probably has the best ATAK plugin. It's the easiest to quickly attach devices, it's the easiest to create networks, it's the easiest to upload keys so that everybody is on the same encrypted network. And then it integrates perfectly with the contacts, so sending things to the entire Beartooth group or a specific Beartooth group or a specific Beartooth user is pretty simple. When I have been testing these units, my kids were able to use it pretty well with very minimal instruction, even though the main thing that they did was just, talk on the radio with the push-to-talk button. Now, once you have this device connected to this ATAK end user device using Bluetooth, you can connect to a regular Bluetooth headset just fine. The issue is going to be if you want a standalone Bluetooth push-to-talk button, or you want something that connects directly to your Sordens or your Peltors or your various other expensive over-ear comms. That only gets tricky because there are so many different ways to skin that cat. It's very doable. It's certainly more tricky in the modern era where phones don't have plugs anymore, but there are adapters that can do it. Ironically, the hardest thing to do is that push-to-talk button, but there are different companies, their names escape me, but we'll put them up on the screen right here, that have Bluetooth headsets with push-to-talk buttons that work with Bluetooth and work with Beartooth and work with ATAK, and you'll get a pretty seamless experience with those. Now, the other thing I will talk about for usability is these devices are all really small. The Beartooth device weighs about 6 ounces, the goTenna weighs about 5 ounces. You can make your Meshtastic devices very small and weigh a very small amount, and yet because they are operating with lower power and much more limited bandwidth, the batteries last for a long time. The Beartooth has 2 or 3 days of battery, and all of this fits in a really small package that has no wires or plugs or anything, even though you could run it off a USB-C battery pack for much longer if you wanted to. And even though this case isn't exactly waterproof, which we'll get to in a little bit, you could put this up in a high place with a USB-C battery pack and leave it there for many days. And it'd be a very important part of your entire network as a repeater node. So there's a lot of different ways that you can use these, and they're just so much cheaper, so much lighter, and so much less power hungry than those MkII and Silvus radios that they have an entirely new way that you can use them. Yes, you can just throw them up into trees as repeaters if you have unlimited money like the United States government does, or you can have them in really small packs and you can do that Bluetooth to your end user device, and it's just small and slick and really easy to work with. But the other thing that's fun about these little devices that are small is that you can put them up into drones. If you were to put one of these on a drone and take it up several hundred feet, or whatever the FAA allows in your particular jurisdiction, you would have a tremendous amount of repeater power. You now have miles of range as opposed to 1 or 2 kilometers through open, sort of broken terrain like we have here. That gives you a tremendous capability to connect people who are further afield. And you can modify these things to make them a little bit more drone friendly. So for example, if you were to take the Beartooth control board out of this box, you're down to like 3 ounces. And because this is like a 3-day battery, you don't need that for a 30-minute drone flight, you could put a much smaller battery in here, get it down to like 1 to 2 ounces, put that in the sky for a little while, have really good digital repeating capability over a long range, all sorts of interesting usability capabilities open up with these smaller radios. However, I do want to point out that in the real world, nothing works as well as advertised. That 1 or 2 kilometers that you can easily see in slightly broken terrain with the Beartooth radios drops considerably once you're in the jungles of Tennessee. And that's going to be true of the Meshtastic radios. It's going to be true of the goTenna radios. And actually, it's probably going to be much worse with the MkII and even the Silvus if they're operating in that 2.4 gigahertz range. The ability of that signal to penetrate some obstacles is considerably less. So this 900 megahertz space is actually going to be better for certain things. A few months ago, we made a video that visually demonstrates how different kinds of RF energy will travel through different materials and be affected by different types of terrain. So check that out if you want a better understanding of this part. That limited bandwidth that you have is actually going to be even more limited once you start using it, because there is no free lunch. The beauty of the mesh system is all the forwarding, but the downside of the mesh is that your radio is no longer just sending your traffic and listening to other people's traffic. Your radio is now retransmitting other people's traffic. So if you have 100 kilobytes of bandwidth, you get out of the real world, it's more like 10 kilobits of bandwidth is available to you. 8 or 9 of that is probably sending other people's messages throughout the network, and you have very little left for yourself and your own messages. And these different radio systems handle it in different ways. So the Meshtastic just kind of floods the network. Every node that receives traffic, receives packets, passes them on. It's pretty inefficient, but it's great for error correction. The downside is this network slows down the fastest. And that's kind of how it was designed. Remember, LoRa is an Internet of Things protocol that is supposed to connect your toaster to your refrigerator to your regular Wi-Fi so that you can just have all of your appliances connected to your smart house somehow. It isn't a real-time tactical network. Beartooth is a little bit more complicated. It uses XB, which is technically older, but in some ways it's better and smarter. Instead of just flooding the entire network with packets, it does figure out a dynamic routing system, and it does actually route messages through more efficiently. So you have more of that bandwidth available as you do stuff. And then goTenna has something called Aspen Grove, which is also a very sophisticated network routing system, but it is their own. Now, speaking of the real world, there are some privacy and security issues with these different platforms. Because Meshtastic is built on LoRa, which is a widely adopted standard throughout Europe and somewhat adopted throughout America, there's a lot of potential exploits and issues. The good news is that Meshtastic itself is an open source program, so you can look inside and you can look for backdoors or problems or issues or bugs or help fix them, but it's all running on top of LoRa. It's running on top of things that are running inside of LoRa firmware that you can't really control and on chips that you can't really see inside of. So there are some real world exploits and difficulties with different chips, and that plays out on paper, but also in the real world. Beartooth is a little bit better because XB Pro is a better system, and then goTenna is a little bit better still because it is largely their own stuff, and I believe that they've done a better job of securing it. But I would say that probably the real winner here is Silvus. Silvus has their own hardware stack and their own software stack, and they have built it entirely around electronic warfare considerations. So that's probably the winner if you know that that's an area that you're going to get into. So usability has a lot of different variables to consider. Now the Meshtastic units though do actually have a kind of an interesting advantage over some of the others. Generally speaking, these T-beams, for example, have a tiny screen. So you can receive and read messages on these devices without connecting them to a computer or to ATAK or to anything like that. And depending on your use case, that might be kind of handy. They can have a little GPS receiver in here, and they can be a tracker that's attached to a dog or a vehicle or a small child, you know, whatever sort of use case you have. And I should probably mention another device I'm not really talking about today called the Link Pro, which is sold by Otto. The Link Pro is its own device that fits kind of in this category, but I don't have a lot of experience with it. I've never used it in the field. I'd only ever seen demos in hotels, so they don't really count. But the Link Pro is essentially low raw under the hood, something that is not Meshtastic on top, that is proprietary to them, but it also has a small screen. It works really well with ATAK, but you can also use it without ATAK, and you can also use it as standalone trackers. So it's cool, but it's priced kind of more up here, and it gives you some performance that's more like here. So that's probably why I'm a little less excited about it. But now let's talk about how they are built and the durability. The other thing that Meshtastic brings to the table is almost infinite variability and configurability. There are tiny development boards, there are bigger development boards. You can have some with e-ink paper that are really power friendly. You can get some that are built out the way that you want them to in a waterproof Pelican with a large battery and a solar panel on the back so that it's active in the sunlight for months at a time. You can build them out however it is that you want them to be. There's even Meshtastic devices that have little keyboards on them so that you can type new messages without connecting them to ATAK or to phones. The sky is kind of the limit, and you can make almost anything that you want, but you do have to make it basically yourself. And it's an open source project, which, as I mentioned before, has some advantages, but it also means that there are constant updates that fix one thing and potentially break another. There's people who are pulling the project in different ways, which is good, but it might break stuff that you are using and nobody else was, which is bad. So there's just a lot going on there. If you're a tinkerer, this is a fantastic place to work and to be. Then over on this side here, you have the more professional stuff. goTenna Pro has fantastic fit and finish. The devices are rugged. Bunker Supply has made tons of additional cases and mounts, so they're incredibly well supported from a third-party perspective. They're waterproof. They're not bomb-proof, but they're close. That's just fantastic. And then Beartooth, once again, is exactly in the middle. You don't have to build it yourself. It comes out of the box completely ready to go. There's absolutely no messing around. It's just turning it on and opening ATAK and hitting the connect button. But it is still, you know, a pretty simple board inside and this 3D printed case, which is fine, but it's never going to be as waterproof or even as water resistant as proper injection mold. This is good nylon 11, but it's also permeable. So you don't have to make the case yourself, but it still is, you know, right there in kind of no man's land between the two. You don't have the same level of customizability with Beartooth, but there is another Beartooth product that I should mention now, which is a gateway. This is something that has a much more powerful computer inside. It has the Beartooth radios, but it also has regular Ethernet ports, and that will allow you to run your own TAK server locally or connect to the internet through some other means, like, say, a Starlink terminal. And now you can connect your Beartooth traffic on your TAK server to any other traffic that you can connect. So now you could work with goTenna traffic, with Meshtastic traffic, with MkII traffic. You could tie them all together using that. So there are some additional Beartooth tools, but it isn't something that is infinitely configurable the way that some of this other stuff is. So now that we've gone over all of these different variables, the range, the privacy, the security, configurability, durability, stuff like that, we can come back to our performance graph. Price and performance, and It's almost kind of a straight line across here, and Beartooth is smack dab in the middle. Now, it does kind of depend on what it is that you are doing. If you do a lot of SAR work and you connect directly with first responders, they are more likely to have goTenna stuff. And if you're doing that, you already have your NIMS and your NICs and your other certs, so your business band radio license is not going to be hard for you to get. This is the space that you need to be in. If you are the kind of person who looked at the inside of the Beartooth radio and you said, I could do that, well, that's what Meshtastic is for. Meshtastic is going to be great, not so much for those high-speed tactical applications, but building out larger community networks. The slower messages are an issue for like wildland firefighting or sort of ATAK tactical stuff, but not bad for a lot of other emergency comms. And building out Meshtastic so that you have solar-powered repeater nodes and small stuff on your kids and your dogs and medium-power stuff that connects to your end-user devices, that is a fantastic place to play if you have the DIY capability, and you'll get in it for cheaper. So depending on what it is that you are doing, what it is that you want to do, and what skills you bring to the table, you're going to end up in different buckets. But if you're watching the TREX Labs channel right now, and you're a TREX fan, and you want to do mobile ad hoc stuff with ATAK, and you would like to do it for 750 bucks, Beartooth is right in the middle. It's the ATAK easy button, and it has that lower probability of intercept, and it has the encryption, and it doesn't have the licensing requirements, and it doesn't require you to 3D print your own cases. Like, it's kind of the sweet spot for you, I think, probably. So if you go to the Beartooth website, you can get it for that code. I mentioned TREX 40 is the code to get you 40% off, and it turns into 750 bucks per node. Now remember, one node doesn't do anything, and two nodes doesn't do very much. With mesh radios, you actually want to build a mesh of multiple nodes, so it does add up. But I want to call out Beartooth specifically for another reason. Not only have they brought something in that fits in this performance price area and solves a lot of ATAK issues very elegantly, but I'd like to point out that almost every company that we've talked about on the table has tried to do consumer radios for citizens before. So this is the Beartooth 1, and it used LoRa, and it was supposed to be something for regular folks. And goTenna built the same thing. This is the goTenna mesh, which uses some of their own technology, and this was sold in REI, and my favorite part is it came in TREX Arms main channel, TREX Arms Armory channel, and TREX Arms Lab channel colors, but these devices never really caught on. Even Link Pro had a non-pro version that was available for people to buy and use, and they didn't buy it and they didn't use it. And all these companies sort of turned their attention towards the professional market, and I don't blame them, because it's very hard to sell decentralized radio equipment that is hard to use and expensive to people who already have spent $100 on easy to use and also kind of expensive cell phones. Much easier to sell directly to folks that already have a need for radios and a subsidized radio budget. But Beartooth, I think, has done more than anybody to try to stay in the space where they can serve civilians and make things that are accessible and make things that are affordable. And so I want to give them a specific shout out as being somebody that is worth supporting, because they would like to support us. And that is the reason that we don't make any money from that affiliate code. We're trying to solve this problem of decentralized communication for you. And I am thrilled that there are as many companies as there are in this space, tinkering with this stuff, experimenting with this stuff, and delivering products to market. Several years ago, at the very beginning of 2020, I was this close to making a TREX Meshtastic device, and the supply chain disappeared and I got busy and it never happened. So I'm thrilled that there are companies that are doing that work, because it is very important to us, and I think that in the future it could be very important for you. So there is the official recommendation for 2024, August of 2024. But I do want to make a quick comment about the affiliate code. We're not getting paid for you guys using the affiliate code because we're trying to support this product. It doesn't mean there's anything wrong with affiliate codes or coupon codes or revenue sharing. I'd like to point out that gun tubers and YouTubers in general get a lot less money than you think. We've been able to monetize almost all of the videos on TREX Labs, and you guys have watched a bunch of them, and we have made an average of $100 per video, which covers one of these, basically. So the only way for people who are doing this research and producing this kind of content to monetize their efforts and be paid for the labor that they've done is sometimes to partner with other companies, and I'd much rather that those companies partner with people who are doing that educational work than just general advertisers. So we're not commenting on that, we're just commenting on how much we want to support this particular area.